guys, today we have section 5-7 on roots and zeros. Alright, it's a bit of a longer lesson. There's going to be 4 types of problems we're going to be having today. Most of them are things that we've done before, and we're just adding just a little bit onto, so hopefully it's not too bad. Okay, the first type of problem we're going to have is solve each equation and state the number and type of roots, or zeros. So we should be able to do this from all prior knowledge before here. Okay, this isn't anything new. So just x squared, I should be able to solve this by factoring. Remember, I have a number in the front, so when I have a number in the front, okay, we have to multiply. I'm looking for what multiplies to negative 12, okay, and what adds to 1. Alright, so 4 and negative 3. So that's how I split this middle one up. 2x squared plus 4x minus 3x minus 6. Okay, didn't change it. 4x plus a negative 3x is still 1x. Alright, front 2, back 2. What's common to the front 2? 2x. It's going to leave me with x plus 2. Alright, what's common to the back 2? A negative 3. X plus 2. Front numbers, 2x and a minus 3 go in one set of parentheses. And then the parentheses are already there, x plus 2. Okay, what makes each one equal 0? Remember our trick. Opposite of the back number, so positive 3, divided by the front number if it has one. So positive 3 divided by 2, or negative 2 divided by 1. Okay, so we have 2 real roots. Okay, another x squared one. Okay, it's not going to be a factoring one. Let's just try to solve this normally. I would subtract 1, then divide by 4, and then square root. Now, square root of a negative, it's a negative 1/4, square root of a negative, okay? So that's going to be I, right? We can break this up into 2 here. We can go square root of negative 1 over the square root of 4. So we're going to have I over 2. And this is going to be plus minus. It could be a positive one, could be a negative one. Okay, so there's 2 of them there. A positive version of it and a negative version of it. Okay, so that's 2, and both of those were imaginary then, because they both involve I. 2 imaginary roots. Okay, so both of those we've known how to do from earlier lessons. Okay, just kind of dusting off the old memories there, the old techniques. Alright, this one's from a little bit more recent. This would be a difference of squares, right? This would be 4x squared squared minus 9 squared. So what's my difference here of squares? Alright, we're going to have 4x squared plus 9 times 4x squared minus 9. Okay, and again, we have another difference of squares right here. This is 2x parentheses squared and 3 squared. So this one's going to break down into 2x plus 3 and 2x minus 3. Okay, so what makes this one equal 0? Positive 3 over 2, negative 3 over 2, and this one we have to do a little work on. 4x squared plus 9 equals 0. 4x squared equals negative 9. X squared equals negative 9/4. And just like the last one here, when I do the square root, we can it's going to be like one big square root, but we can break it apart into two square roots. Plus minus 3i over 2. Okay, so I'm going to have two reals and two imaginaries. Alright. So that's going to be your first section in the homework. Is just solving and then stating the number and type of roots. Real or imaginary, how many there are of each. Okay, and you're just going to have to use your old solving strategies there. Okay, the next thing we have is Descartes' rule of sign changes, rule of signs. If you can't read my handwriting, it's in the book on page 360. Okay, the number of positive real roots is equal to the number of sign changes in f of x, or less than that by an even number. So for example, if you got 8, there are 8 sign changes, then you could have 8, or 6, or 4, or 2, or 0. Or if there was 5, then you could have 5, or 3, or 1. But then you would know that you couldn't have a 0 because 0 wasn't an option. The number of negative real roots is equal to the number of sign changes in f of negative x, or less than that by an even number. Alright, so let's see what that looks like. So the f of x for the positive ones is pretty easy because you don't have to change anything. So I'm looking for sign changes. Positive to negative, there's 1. Negative to positive, there's number 2. Positive to positive, positive to positive. Okay, so there was only 2 sign changes when I went from positive to a negative and a negative back to a positive. So there's 2 sign changes. Okay, so that's going to tell me that there are 2 positive or 0. 2 or 0 real positive roots. Okay? What about our negatives? So for that we have to do a little work. We have to put negative x in. So I put a negative x for all these are. And you kind of have to use your brain a little bit here. Okay, so you kind of have to go through and evaluate this right now without even knowing what the number is. Okay, and sometimes I'll pretend that there's a negative number in there to help me. Alright, so think of like this is a negative 2. If I had negative 2 to the 4th, okay, that's going to be negative 2, positive 4. Negative 8, positive 16. So when I have negative 2 to the 4th, it doesn't really change. It's going to be positive 16, the same as if I would have had a positive 2 in there. So this one still doesn't change, x to the 4th. Okay, what if I had negative 2 to the 3rd? Does it change the sign? Okay, negative 2, positive 4, negative 8. So yeah, this is going to have a negative sign on it now. So that's going to change this sign. An even power won't change it. Odd power, x to the 1st, it will change it. Okay, and that's the pattern and that's the shortcut. For every even power, it won't matter, it won't change it. Odd powers, x to the 3rd, x to the 1st, it will change the sign. Even powers don't change it, odd powers it does change it. And now I can go and count sign changes. Positive, positive, negative, there's 1. Negative to a positive, there's my second one. Okay, so I will have 2 or 0, because it goes down by 2, it's down by an even number, 2 or 0 real negatives, negative roots. Alright, and then for my imaginaries, that means I could have 4, let's say both of these were 0, 0 and 0, well then I could have 4 imaginaries. Okay, another option is I went with 2 and 0, or 0 and 2 it worked out to be. Well, that would still leave 2 imaginaries. Or what if it works out perfect here with both of them working here? 2 positives, 2 negatives. Then I would have 0 imaginaries. Okay? So 4, 2, or 0 imaginary roots. Next up, another problem just like it. Okay? So f of x, positive roots. Let's check it out. Negative to a positive, so there's one sign change. Positive to a positive, it didn't change. Positive to a negative, another one. Okay, so I'm going to have 2 or 0 real positive roots. Okay? F of negative x. Okay, and remember what I said, it's the odd powers that change it, and for this case, they're all odd powers. So this is going to be now a positive x to the 5th. And this is going to be a negative minus 13x to the 3rd. X to the 1st, that's odd. It's going to change the sign, minus 19x, minus 36. Okay? So, positive to a negative, there's 1, negative, negative. So this one's going to have 1 real negative root. Now, 1 real negative root, it's gonna have that 1 real negative root because I can't go down by an even number. All right, I can't go to 0. If I go down by an even number, I won't be at 0. I'd be at negative 1, and we can't have a negative of a real root. Okay. So what are my options here? Okay, I could have 2 or 0 real positive roots. I already have 1 real negative root for sure. I'm going to have 1. Okay? So, what if it was 0 and 1? Well, it's x to the 5th, so that would leave me with 4 imaginaries. Or what if it was 2 and 1? Okay, then I would have 3, and I would still need 2 more. 4 or 2 imaginary roots. Notice this one doesn't have an option of 0 imaginary roots. I'm at x to the 5th. I'm going to have 5 roots. Okay? And there's a 2 that I could have, or a 1. So if I use the maximum on both of my real and real positives and real negatives, I'm still going to be short. I'm still going to need 2 imaginary roots. Okay? So just be careful with our possibilities here. And you know what, we will call it a day there, and we'll pick it up with the rest of them tomorrow. Again, if you need to see these again, you can search Handke Algebra 2, and this is 5.7 roots and zeros.